Hi guys, so the idea of this video is just to do a short recap of everything we've done so far with the athlete monitoring data. And we're not going to do any coding in this video. All we need to look at are the monitoring Vis 1 and the monitoring Vis 2 workbooks. But before we do that, let's just remember why we decided to do a mixed model. And the reason that we chose a mixed model for these analyses was to account for the missing data and the clustering within athletes. And we've worked through three different types of mixed model. We've worked through a random intercept model with which estimated the means of different categorical variables. We've estimated a random intercept model which has used a covariate to create random intercepts with a slope that have the same slope as the intercept. And then we've done a random slopes model, which allows both the intercepts and the slope to vary from the grand mean intercept. And the amount of information that they give us for each specific individual is quite different. And as you can see here, this is the first model we did. You can see the intercept is flat, and then we have these means that are estimated as differences from the intercept. Now, if we use athlete 9 as our guinea pig for this, you can see that the means themselves don't really fit that well for athlete 9. And even when we put in the random intercept for athlete 9, the means still aren't that great because you'd quite like to have, where are we, sorry. There we are. The means still aren't that great because you'd quite like to have this one probably slightly lower, this one maybe there, maybe slightly higher, and then this one would definitely be higher. And the problem with grouping the data like this is that you can't get those estimates for each individual. So we said, okay, we can't get those estimates. How about we look at this in a continuous manner? And we look at this in a continuous manner because these values aren't all equal to the same amount. So let's try and think about if we can use that to get a better picture of what's going on. And so this is a situation we're in with monitoring Vis 2. We can look at the random intercept model for the mean and for athlete 9 now to see how it looks. And you can see that the random intercept gives a little bit of a better picture, partly because the data is no longer in straight lines. So we actually have a value for each of the data. We get a better understanding of what's going on. However, it still doesn't fully capture the slope that we would expect for athlete 9. And in order to unlock this slope, we had to use a random slopes model where both the intercept and the covariate, which in this case was a mean-centered sleep, could vary for each athlete. And when we did that, we ended up with a random slope intercept that was fairly similar, but a random slope for athlete 9, which was very different. And you can see how this now really actually looks at the data, really shows the trend of the data really well. And we can look at countless other other possible athletes for that, and you can plot some of your own for that. But all I wanted to do was illustrate the differences in a really short video so that you can see it really explicitly how much this random slopes model has helped in this situation.